Hi guys, welcome to Native Mobile Bits. My name is Sachin and today we are going to learn about data structures using KOTLIN, and we will start with this very beautiful concept called linked list. And a quick recap. Till now we have covered about these basic data structure like array list and array list inside KOTLIN in our previous video. Let's start. Linked list basically is a collection of objects, like this is one object and this is another and so on. So linked list object is called node, and a node has two responsibility. One, it needs to hold some value, and then it needs to hold the address reference of the next node. So let's consider one example. So this is one linked list with 4 nodes, and as we learned that nodes need to hold two fields. One is the value of that node and another one is the address of the next node. Same thing is happening here. This first node is holding the address of this next node, which is stored at this location. So it is holding that reference. And this second node is holding the address of this third node here. And this third node is holding the reference of this fourth memory over here, like this. And then when any node is having null in the reference area, that means there is no next node associated. That will be the end of the list. So by now we can understand that linked list is having multiple nodes. So let's start creating one node for our linked list, and let's create one package linked list. Inside this we will create all the files related to our linked list implementation. And to start with, let's create one data class, and data class basically holds some value inside it, and we can name it as node. So this will be our base node of our linked list, and we can assign data class here. Linked list can be of any type. Right now it is holding string values here, right? String. It can also hold integer and other type of values as well. So we can give some generic type here, t. By adding this t here, we are saying that this node can be of generic type. We can assign any type of values here, and then we can add our constructor. And here what we need one value for the node element, this value basically. So we are adding the first parameter value, and it can be of generic type as well again. And the next parameter we will assign the next node. So we can assign next node one parameter here, and this will again be of the same generic type, node t. Okay, like this. And this can also be null, because in the end there will be null inside our linked list address reference. This means that this next node can be of null type as well. So let's recap what we have done till now. We have created one data class node, and this is of generic type. And then we have added one primary constructor which is having one value and next node reference. Okay, and as this is the data class, we can override toString method here. And for now, let's delete this return statement. So we can already see that linked list will end when this next node reference will have null inside it. So let's implement the same condition inside our node class. So let's check here. If next node is not equal to null, that means there is some value inside this, and we can return here these values. So we can form a string template using this $symbol value, and then we can add normal symbol to reference that this is the next element in the right side. And then we can take this next node reference, and then we can do this to a string. So we have added one logic, like if this next node is not null, so we are returning first the value and then we are returning the next value. Else, once this next node is null, then we will just return our value, and we can add inline return statement like this. This is our basic node we have implemented. We are checking very simple thing, like if the next node is not equal to null, then we are returning both the value, the first value, the current node value, and then the next node. Else we are only returning the current node value. Okay, now let's create one file and name it example, and inside this override our main function. Now let's try to use this node class inside our example class, and here let's create some nodes. We can just name it node 1 for now, and we can use our data class node, and here we can pass the value first, maybe 1, create another node and pass value 2, and so on. We have created 4 nodes now and we have assigned value. So if we see the implementation, each node has one value and reference to the next node. So we can do the same thing here. Our node 1 has reference to next node like this. So we have assigned node 1 value here 1, and then we have assigned node 1 dot next node equal to node 2. This means this node has reference to this second node, and similar way this second node has reference to this third node. So we can do the same thing here as well. Next node equal to node 3, and similar way node 3 can has next node 4 like this. So this is our normal linked list implementation, very basic thing. We have started with this. We will enhance this shortly. So if we want to print now this node 1, if we check our logic, first it will check here that okay, if this next node is not equal to null, so we will print the value of the current node and then it will print the value of the next node. Okay, till the time this next node is null, that means in the end when we will reach till node 4, then once we reach out to our last node, this node 4, it does not has next node value, then it will just print the node 4 value and it will end the linked list. So let's try to run our program. Is printing our basic linked list. If we remove this node 4, or if we comment this node 4 for now and we don't add any next node inside our node 3, then let's see what it will print. It will just print till 1 2 3. Okay, so this way we have created our node class, and node class has one very basic logic. It checks if the current node has any next node, then it prints the current value and it indicates the next value as well, else it just print the current node value. So far, we have learned about how we can create a node for our linked list. In the left side, you can see a linked list element which is called node can hold two fields, one value and one reference to the next field. Same thing we have implemented here in the right side. We have one node class. It can hold one value for the current node and one next node reference it can also hold. So this implementation is done. Now let's move towards creating one linked list where we can insert or delete or perform some other operation on our linked list using this node class. Okay, let's create one class here and name it our linked list and hit enter. And we will make our linked list as generic type so that it can hold either integer or a string or any kind of value. So let's add generic t here. Okay, and then let's take a closer look on this linked list example over here. So it has one head element, one tail element, and head element is the first node of our linked list and tail element is the last element of our linked list. So let's define two variables here, private var head, and this will be a node of generic type again, and then it can be of null as well. And then let's create one tail variable similar way and name it tail of node generic type, and then it can also be null. Okay, and then we would also like to calculate our linked list size in some cases. So let's define one variable size as well, and this will be of integer type and initial size will be 0. Okay, and let's also define one function to check in some condition we would like to check if our linked list is empty or not. So we can just define is our linked list empty, and then here we can return boolean true or false. We have learned this already in our Kotlin crash course. And then here we can add some condition. If size equal to 0, then return true, else return false. So now we need to return one boolean. So either we can take this return statement out of this if statement like this, or we can directly do like this. Return size equal to 0. So this code expression is also checking the similar condition. If size is equal to 0, then return true, that our linked list is empty, else return false. Okay. Then in some cases we would like to print to string method of this class, and here we will check if our list is empty. Okay. So for checking our list, we have this method. So we will check if our linked list is empty, then we will return some string. Our linked list is empty, else we will just return our main node head dot to string. So this head variable is a node type, and inside our node class we have already written this logic, like till the time next node will be node null, it will keep on printing the values like this. So this way we are checking that okay, if our linked list is empty, then it will return one empty string, else it will return the complete linked list using our node implementation concept. Okay. Now we need to return this string here again. So we can take this return statement out of our if expression like this and remove from here as well. So now it will return the string to this function. Okay. This is our very basic linked list initial implementation. It has one head and tail variable. It has one size variable, and then it has one normal function where we are just checking that if size is equal to 0, that means our linked list is empty, else we are returning our complete linked list using our node implementation like this. Next, we are going to add some methods which will allow us to add some values inside our linked list. So there are three different ways we can add some values inside our linked list, which is push, append, and insert. We will cover all of these operations one by one. So let's start with push operation. So basically push operations add a value in the start of the list. So for example, let's say we want to push these three elements 10, 20 and 30. So if we try to push first element 10, so inside our linked list there will be one node. This will be the head and this will be the tail, as there is only one element. Okay. Then when we push the next element 20, then there will be two nodes and 20 will come in the front. Okay. 20 will be the head and 10 will be the tail at that time. Okay. The moment we push the next and the last element 30, 30 will become the head node of our linked list. It will get pushed at the start of our linked list. Okay. So this will become head and then these two elements will be there. This way our linked list output in the end will be 30, 20, 10. Let's try to implement this push operation now. So here let's create one function, push element, and it will take a generic value. So we can just add one parameter value of type generic t, and then inside this function first element, whenever we are pushing first element inside our linked list, that will become both head and tail, as there will be only one node like this. Inside this we can update our head variable with one node object like this, and node object just take two things, one value and then next node reference. So we can assign value which we are getting inside this function as parameter, and then for next node we can assign the same node head. Okay, because in the first our head and tail is only the first element. Okay, then we can check that if tail object is null, so we can assign head object itself to the tail object. This is exactly like this case, and then now one item, one node is inserted inside our list, so we can increase the size with 1. Okay, so this is the push function which we have created, and inside this we are just pushing one item inside empty list. So the new node in the first will be both head and tail of the list, and since we have pushed one element inside our list, so we have increased the size of our list. Okay, now to check this push operation, we can just create one file. Let's create one main file and override main function over here. And inside this, let's create one object of our linked list and assign with this our linked list and assign type integer and add one empty constructor over here. And then let's take our linked list object reference and call this push element function. And let's try to push some elements as we are having in this example. So let's add 10. Then next element we are going to push 20. And then next element we are going to push 30. Okay. And then let's try to print our linked list and let's run our program. And let's try to print our linked list and run our program to check the output. So our program has been executed and we can see that we are getting this output. So in first step, 10 element is pushed, then 20 and 30, and push operation always push the element at the starting. That's why we are getting this output. If you notice in code, first we pushed element 10, then our linked list became 10. Then we pushed 20, so in the starting it added 20 as the first head element and then 10 became tail. In the next step, we pushed the 30th element and then 30 become the head of our linked list and then 20 and 10. 10 became the tail. This way we are getting this output. So let's comment this and maybe add one for loop, okay, and add one range 1 to 10, which we learned already in our previous Kotlin crash course. And inside this, let's push each element from this for loop inside our linked list, okay. So we are pushing 1 to 10. So always remember we are using push operation. So inside this first it will push 1, then in the next step it will push 2 and 2 will come in the front and so on. So let's try to run this and see the output. Yes. So first it pushed 1, then in the second step in the starting it pushed 2 and then 3 and then so on till 10th. And in the end 10 became the head of the linked list and 1 became tail of the linked list. This way we can use this push operation to insert an element at the start of our linked list. Okay. Now let's move on to the next operation and that is called append. So append is the exact opposite to the previous push operation. So whenever we use append operation, this adds the value at the end of the list. Okay. So let's take an example. Suppose we are trying to add these three values using append operation inside our linked list 10, 20 and 30. So first it will add 10 and this 10 will become the head and the tail both because there is no node previously. So this is the first node, it becomes head and tail both of our linked list. And then we append this next element 20, so it gets added at the end of the list and now 10 is still the head and 20 becomes the tail of our list. Then we append the next element 30, so this time also 10 is still at the start and then 30 gets added at the end of our list and becomes tail of our list. Okay, so this way if we try to append any number of elements inside a linked list, all the values will get added at the end of that list. First 10, then 20 in the next append operation, then in next append operation 30 came at the end. Let's implement this inside our linked list class. So let's create a function append element. This will also take a value of generic type t. And inside this, we will check that if our list is empty, then we need to make that first node as the head and tail both. So we can utilize this push operation, which is doing the exact similar thing. So let's add one condition. If is our linked list empty? If our linked list is empty, then we can just make that node as head and tail both, and to do that we can just call this function push element and we can pass the value and then we can return from here. Okay, So in this condition, what we have done till here is we have checked that if our linked list is empty, then push one element, and this operation will make that element as the head and tail both, and then we are returning from here. Okay. In next step, when our linked list is having some elements, okay, so we can create one new node, and then we will add that new node as the current tail node. Okay. So to do that, we will just call our tail variable reference, and then tail will not be null because the current element is there already. So that is only the head, that is only the tail. So we are adding this always operator tail. If tail is not null, then we are adding the next node, and we are creating one new node, and we are passing the value which we are receiving inside this function. Okay. And then we are making the current node as the new tail, like this, tail dot next node, and then one element is inserted, so we will just increase our linked list size with 1, like this. Okay, so this is our append operation. Let's go through it again step by step. So first we come inside our append element function, we check that our linked list is empty. Okay, linked list is empty as of now. Then suppose we are getting these values 10, 20, 30, 40. Okay, then we come inside this, we check, okay, linked list is empty, then we push one element. Okay, we push one element, so here our linked list became 10, and we are returning from the function here. So till here our linked list is having one element 10. When the next element is appended, so we come here, we check, is our linked list empty? No, our linked list is having one element which is 10, and this is the head, this is the tail as of now. So we are having a new value 20. So we do this tail dot next node, and we add this new next node 20 as the new tail node. So we have added the reference here. This 10 is having one new reference to the next node which is 20, and then we make this 20 as the new tail here. We are making this tail dot next node 20. So now we have the linked list here like 10, and 20 is the new tail. In the next round, we check if linked list is empty. No, linked list is not empty. Same process happens, and then 30 comes at the end and becomes the new tail. Similar way, 40 also comes, and linked list is having some element, it's not empty. Then it comes here, it adds the new next node reference inside this 30 and add the new tail as the new member here, new node 40. This way our append element function is working. Okay, let's use our append function inside our main class, and let's see how we can append some element using this inside our linked list. And let's create one new file, append example. We'll keep all the code in GitHub for future references. Okay, and inside this let's override main function, and here let's create one object of our linked list implementation. Our linked list equal to our linked list of type integer. Okay, like this. And then inside this let's try to append some element. Let's say we was having these inside the example, so let's try to cover this example first. So let's append the first element 10, then we can again append the next element, and so on till we append all of our elements like this. And then we can just try to print our linked list. Let's try to run this very basic example for now, and let's see the output. So we can see this time our output is coming like this as we expected. So first this 10 is appended, and then 20 came and it got appended in the end of the list. Then 30 came and it came in the end. Then 40 came and it came in the end of the list, and it became the tail of the list. 10, which was the first addition to our list, it still remains the head of our list. So let's enhance this code little bit. We can use a scope function also here. We can use our linked list dot apply, and this gives us the reference to our linked list. Inside this we can just take all of these functions directly, and it will get added inside our linked list. We no need to every time write our linked list dot. So let's comment this and run our program again. so we get the same output. Okay, so we can use scope function as well, and here we can apply any function, append element, or previously we was having push element. So if we try to push one element here, let's say we want to push 50. Okay, let's see what happens. We already know that append add one value in the end of the list. Now we are using push. We have this much linked list. Now we are trying to use push element function. So what do you think what it will do? Answer in comments before going forward in the video, and let's see. Now let's run our program and let's see what it will do. Okay, so it will push the 50 at the starting, you see. So append always push the elements in the end, and then if we try to use push element function, push always add one element in the front of the linked list. This way append and push element works. So for now, let's cover one another example. We was having one for loop. So let's write one for loop here as well. I in 1 to 10. Okay. And here we can use our linked list object dot apply. And here we can just append the element I. Okay. Every element inside this for loop. Let's comment this example for now again. And let's run our program. So we are having one for loop with one range 1 to 10, and then we are having a scope function applied to our linked list object, and we are appending all the elements coming out of this for loop. So this way we are getting this output. So we also use this for loop inside our main class when we was using this push element, and we was getting this output like this, right? Okay, so let me add one more linked list here. Linked list built using push operation inside the same for loop. Let's use the same linked list which we just created, and apply and push the same elements. Okay, so we are having two linked lists now. Inside one linked list we are adding all the elements using append operation, and inside another linked list we are adding all the elements using push operation. Okay, and then let's try to print our both linked lists. Here add one string template using append. Okay, and then refer to a linked list, and here let's add using push and refer to our linked list. And now let's try to run our program. Okay, so you can notice that append operation is always adding the elements in the end of the list. Okay, the more element come out of our for loop, all of those elements gets added in the end of our linked list. And on the other hand, push operation is always adding the elements at the front. Whenever any new element come out of our for loop, push operation always add that element at the start of our linked list. So this is the difference, okay, between append and push. Okay, after these two operations, we have one more operation to add value inside a linked list, which is called insert. And insert can add a value after any selected node inside our linked list. So inside this operation we have two sub operations. We need to first find a node after which we want to add some new node, right? So we will be having a linked list, and then we will find one node inside that, and then we will insert the new node after the node we found. So it will look something like this. We will be having one linked list. Maybe we are having a linked list with these elements 10, 20 and 30. We want to push one node 40 after this node 20. Okay, so first we will find this node 20, and in linked list in this operation we will traverse through head one by one till we reach here at this node, and then we will insert the new node value after this node. Okay, so let's implement this and let's see how we can do this. So let's start with this first step where we will write a function to find the node at any given index. So we will just write a function with this fun keyword, and let's name it find node at, and we can pass the parameter as given index. Okay, and this will be of integer type, and then this will return us a node of generic type. It can be anything, integer or a string, and let's add parenthesis. So this is our function, and this node can be null also, so let's make it nullable. So now this node which is coming out of this function can be null as well, and inside this we will start with the head node reference. So let's create one variable current node, and this we can assign the value here of current head, okay, the first element, and then we can keep one current index as well, which will be 0 in the starting, and then we can write a loop in which we will loop through all the nodes available based on this given index. So let's write one while loop here, and we will check if the first node, which is our head, is node null. That means if current node is not equal to null and the index where we are currently inside our linked list is less than given index which is coming out of this function. So we have one condition here that current node is not equal to null. That means some items are there inside our linked list, and current index is less than given index, okay, and inside this we will make the new node as our current node. So you just take current node dot next node. This means we are assigning the next node reference inside our current node, and then we are increasing our current index by 1. Okay, so this loop will keep on running until unless our current node is node null and the index, current index where we are inside our linked list is less than the given index here. Okay, and then whenever this condition will execute, this loop will stop, and then we will return the respective found node which will be inside our current node reference like this. Okay, so inside this we are having one index, and then we are having two variables. One is current node, which is holding the head, the first element inside our linked list, and initially the current index is 0. Then we are looping through till the time our current node is not equal to null and our current index is less than this given index at which we are finding the node. Okay, and once we are out of this loop, when this condition does not satisfy, that time we will be returning the node value using this return current node. Okay, so now we have one function which will give us the node at any given index. So let's try to execute this function first. So let's create one file and name it insert example and override our main function. Inside this, let's quickly create one linked list, and inside this we can add this value using this append. So we are having this linked list as of now. Okay, now we have one linked list. Let's try to check the function which we just wrote is working or not. Is it returning us some node or not? So let's use our linked list reference and call this function find node at and pass this given index value 0 for now maybe. And let's add one else operator. If this is node null, then let's print the value of that node. And let's keep this inside println. Okay, like this, and let's try to run our program. Yes, so it is giving us the value 10 at 0th index, which is correct. Okay, now we need to write one function to insert the element after this given node. Okay, so let's come inside our linked list and let's write one function over here. So let's create our insert operation function. We can just define one function insert element. So here we have defined one function insert element. It takes two parameters, one value of the new node which we want to add and the reference of the node after which we want to add this new node. Okay, and then we can add parenthesis like this. So we was using this example, like we have one linked list 10, 20 and 30. We want to push this 40 here between this 20 and 30. That means after 20 we want to add one new node 40. Okay, so inside this, let's add one condition. Suppose this after node which we are receiving inside this function is our last node, maybe our tail. So we can add one condition. If our after node is equal to tail, that means we just need to add one new element at the end, right? Which our append function does. It just add an element at the end of the linked list. So if we are already on the end node tail, this means if our after node is equal to tail, we can just use append function here and add the value like this. This will take care of everything. It will add the new node in the end. This condition will execute. Suppose we want to add this 40 at the end of this 30 element. So we are passing this 30 element here. After node means the node after which we want to add a new element is 30. This is the last node of our linked list. This means after node is equal to tail. This condition will be fulfilled. Then we will just append one new element at the end, comma 40. So this append operation we already have. So this will take care of this condition if our after node is equal to tail, and then we will return from here. Okay. So if this condition does not execute, that means the node after which we want to add some new value is not our tail. Then we can create one node with our node class which we implemented already, like this here. So it takes two things, value and next node reference. So here we can just pass one value which we are receiving inside this function, and then we can add this next node reference with the help of this node we are receiving here, after node dot next node. Okay, and then we can just reassign the next value of this after node with this newly created node like this, and then we can increase the size of our linked list by 1, and that's it. So in this function we was receiving one new value which we wanted to add, and then one node reference after which we want to add our new value. Okay, so we added one check that if our after node, that means after which we want to add value, is equal to the tail, the last node of our linked list, then we will just append one element in the end of our linked list. Okay, and then we will return from this function. If this condition does not satisfy, then we are creating one new node with the value we received and with the after node next reference here, and then in the next step we are just reassigning this new node to our after node next reference. Okay, and then increasing the linked list size by 1. So now let's go to our insert example here, and here we already have one linked list. We are having this 10, 20, 30 elements inside our linked list. So let's comment this, and here let's take the reference of our linked list and call this insert element function, and value we want to add 40, and then after node we can pass with the help of this find node add. So let's define one variable for after node reference equal to our linked list dot find node at, and let's say we pass after 0th index. So this will be our reference for after node, and let's add this here. So this is saying that type required is node of non-nullable type, but this after node reference can be null as well, because this find node method is returning a nullable node. So let's add one safe call here. If after node reference is not equal to null, then do this. Okay, to simplify this we can also write after node reference question mark also. This will give us it reference. This is a scope function, so it will only come inside if this condition is true. That means if this is node null, and here we can write the same condition, and here we can use this it reference of this. Okay, so let's comment this, and here let's print our linked list like this. So here what we have done, first we have taken the reference of the node after which we want to add some element with this help of find node method. At 0th index, after 0th index we want to push some element, and then we are using this insert element function, and we are passing the new value as 40, and then after node we are passing this after node reference which we just calculated using this find node at method. Okay, and then let's try to run our program. Yeah, so first our linked list was 10, 20, 30, then we inserted one element 40 after this node which is coming after 0th index. So then 0 was this 10, then after 10 one new element got inserted which is 40, and similar way if we want to push something after this 20, so we can just change the index to 1, and let's run our program. So here in this case the initial linked list was this 10, 20 and 30, and then it inserted one value 40 after this first index which is this 20. So after 20 one new element got inserted. So let's close all of these files and just open our linked list. So this is our linked list class implementation which we did. It is of generic type. That means it can be of any type, either a string, integer, or float, or double. Inside this we have these operation, push operation, append, and then we have insert operation. And inside this we take help of this find node operation. So these are the operations which we can use to add one element inside our linked list, So let's talk about these functions performance. So this is the time complexity all of these operations take. So push operation directly adds the value at the start of our linked list. So their complexity is big O of 1. And then append operation adds the value at the end. So there also directly we are just adding the element in the end. Therefore, there also complexity is big O 1. And then insert operation also we just add after one given node. So there also the complexity is big O of 1. But the complexity inside this function find node, when we find the particular node, so we go through the loop again and again till the time we reach at the correct node which we are trying to find by the help of this index. So there the complexity is big of this index, like how many time we traverse through the loop, and it just gives us the node. So guys, this is our linked list implementation, and for now we have implemented all the operation which can help us to add values inside our linked list, and in the next part we will cover how we can remove the element from our linked list. Stay tuned, and I hope I shared something valuable information with you today. If you like this video, please like, share and subscribe to my channel, and see you in the next video. Thank you.